Okay, let's spend some time talking about solving two-step equations. We'll start with some starter examples, then move to some harder examples, and then we'll talk about how to use these in the real world. First, let's talk about our strategies. So what we're trying to do, remember, is always trying to, when we say we're solving, we're trying to really get a variable by itself on one side of the equation, like x equals. And to do that, we'll perform opposite operations. So we think of addition and subtraction as opposites, and multiplication and division as opposites. And the key here really, and this is what you get used to after you do several of these problems, is to pick an order that makes it easier for you, okay? So sometimes in a two-step equation, it'll be a lot easier to do one step before the other than the opposite order. And then always check your answers to make sure that you've gotten something that makes sense. Okay, so let's do our first example here. All right, so we have this equation, 3x plus 2 equals 23. We want to get the variable by itself. We don't have the variable by itself. There's two things that are standing in our way. First, there's that 3 that's multiplying by the x, so we'll eventually want to divide by 3. And then there's that 2 that's being added to the x, so we'll want to subtract that 2. The key question here really is what order? Which would we do first? You could divide everything by 3 to get rid of this 3, because then 3 divided by 3 would be just 1, and then you'd have x by itself. But you'd have to also divide the 2 by 3, so you have 2/3, and this 23, so you have 23/3. So you'd be working with fractions, not the end of the world, but it's usually not quite as easy to do. So maybe we should try the other way first, which would be to get rid of this 2. It's being added, so we can subtract from both sides. Let's try that. So if we subtract 2 from both sides, on the left-hand side here, 2 plus 2 minus 2 is just going to be 0. So we'll just have 3x. And on the right-hand side, we'll have 23 minus 2, which is 21. Okay, that's looking great because it's pretty simple to work with here. Now that 3 is still bugging us. It's multiplying by the x, so we do the opposite, which is to divide. And we have to do that to both sides, of course. On the left-hand side, and this is really critically important, this 3 divided by 3, we say those cancel. What we really mean is that 3 divided by 3 equals 1. So you have 1x. And that's what we want, because you just write it as x. And then 21 divided by 3 on the right-hand side is 7. So we have x equals 7. So now we've gotten to an answer that we want, the variable by itself on one side, but we always want to check the answer. So let's go back up here to our original equation and say if we put 7 in for x, we'd have 3 times 7 is 21 plus 2, yep, that's 23. So we can go ahead and say, yep, we feel that that's a sensible answer there. Okay, let's look at another example. And this one with negative numbers. So similarly here, you can start to get a sense of what order might work best. You have a very similar problem here. It's just that you're dealing with negative numbers. You could divide by -2. That would actually work out a little bit better because both of these are even numbers. And so dividing by 2 would not give you a fraction. But we can also do, as we did up here, get rid of this -14 first. And it's being subtracted from our variable, so we want to do the opposite, which is add. So let's add 14 to both sides. And on the left-hand side, then we'll just have -2b because -14 plus 14 is 0. And on the right-hand side, we'll have -24 plus 14. Let's see, what is that? -10. Okay, so now we have -2b equals -10. And now that -2, it's what's standing in our way of b being by itself. It's multiplying by the b, so we do the opposite. Divide by -2, both sides. On the left-hand side, we have just 1b, or b. And on the right-hand side, -10 divided by -2 is 5. So b equals 5. Let's go ahead and check this problem again. So 5, or check the solution. If we put that in for b here in our original equation, we have -2 times 5 would be -10. Minus 14 would be, yep, -24. So we can be confident that we've gotten the correct answer. All right, let's do a couple of harder problems over here. So here's an example of a problem we could solve in two different ways. One will take an extra step and one won't. And the real question is, should we distribute or not distribute with what we've got here? So you might take a look at this problem and say, well, 3 times the quantity g plus 2 equals 12. The best thing to do is to go ahead and distribute this 3 to the g and the 2. Let's try that over here. So then the 3 times g is just 3g plus 2. 3 times plus 2 is 6 plus 6, and then that will equal 12. So can you see how we've moved by just distributing here to this equation here? Now this looks very similar to this one over here. So let's follow the steps in kind of the same order. We'll subtract 6 from both sides. Then we'll be just left with 3g on the left, and 12 minus 6 is 6. Then we can divide both sides by 3. You're getting the hang of this now. And then you have just g, and then 6 divided by 3 on the right-hand side is 2. So you have g equals 2. Let's go ahead and check that answer. If we have g equals 2 here, and we put it in our original equation, 2 plus 2 is 4, multiplied by 3, yep, that's 12. So this is the correct answer. Now notice though that you actually went through 3 steps to get there. You distributed, that's one step. Then you subtracted the 6, that's another step. Then you divided by 3, so that's a third step. There is a faster way to do this. Can you think of what it might be? Well, this 3 is being multiplied by g plus 2. So what if we did the opposite? What if we went ahead and divided both sides by 3? Okay, so what would happen here? This 3 divided by 3 would just be 1. So we just have one of these quantities, so we would just write it as g plus 2. And then 12 divided by 3 is 4. So we'd have g plus 2 on the left-hand side and 4 on the right-hand side. Now that's looking really close to being solved already. We just have to get rid of this plus 2 by doing the opposite. Subtract 2. And then we have g equals 4 minus 2, which is just 2. So you can see we got the exact same answer either way. The only difference is here we did 2 steps on the right-hand side. We divided, and then we subtracted. So when you can find a shorter way to get to the answer to the problem, as long as it's not making it a more complex way, you might want to try that. Let's try one more harder example here. So here we have h plus 11 all divided by 8 equals 2. So there's 2 things standing in our way of getting h by itself. There's this plus 11, and then there's all that's being divided by 8. So you might think, okay, well, let's just minus 11. But you can't really do that because both the h and the 11 are being divided by the 8. So if you're going to subtract 11, you'd actually have to subtract 11/8 after you put the h over the 8, and then you're dealing with fractions, and that can be a little bit more difficult not to make a mistake. So probably the better thing to get rid of first would be this 8. And what's it doing to the h? Yep, it's dividing. So you want to do the opposite by multiplying both sides by 8. So let's go ahead and do that. So on the left-hand side here, same as we've said before, those 8's are going to cancel, meaning 8 divided by 8 is just 1. And so that's just 1 times this thing here. So that's just going to be h plus 11 on the left-hand side. And then on the right-hand side, 2 times 8 is 16. So let's go ahead and write that. We have h plus 11 equals 16. Now that's looking very close again. That 11 is being added, so we'll do the opposite, subtract. And on the left-hand side, we'll have just h. And on the right-hand side, 16 minus 11 is 5. Okay, let's go ahead and check that answer to make sure in our original equation. So 5. Forget these multiplying by 8s here. Let's just think about our original equation. 5 plus 11 is 16. Divided by 8, does that equal 2? Yep, it does. So we can be confident that we've gotten the correct answer there. All right, let's use this in the real world. And there's a couple of strategies here. We're going to be dealing with descriptions or word problems. So let's try some strategies here. First, use a variable for the unknown. You have to figure out what it is that you're trying to figure out, what you don't know yet, and assign that a variable. And then look for starting values, ending values, and rates of change. Okay, let's look at the example to see what we mean by all this. Malik got a $200 cafe gift card on January 1st. He always orders decaf mochas, which cost $5 each. At the end of January, Malik's gift card has $125 left. How many drinks did Malik buy in January? Okay, so this is a word problem, and there's a lot of numbers and words in here, so you might be having trouble making sense of all of it. So let's make sure and follow our strategies. First, what's our unknown? A lot of times we can find the unknown by looking for a question, and usually it's towards the end of the problem. How many drinks did Malik buy in January? That's what we're looking for. So let's assign that a variable. We'll say D is the number of drinks. Okay, now remember our other strategies here. We want starting values, ending values, and rates of change. So what was our starting value here? Yeah, that's right. It was $200, how much the gift card started with. So let's go ahead and write that down. And then what was our ending value? Yeah, 125 there. So that's our ending value. And what's our rate of change? Now, when we say rate of change, we mean for each thing that happens, like each drink that's bought, we want to know how much the balance on the gift card changes. And you can see that from right here, we can see the rate of change is 5. So we can write that as well. Okay, now let's try to put all this together into an equation that tells the story of what happens. So we can always start with the starting value of 200. And we know we ended up with the ending value of 125. And then something happened in there. We were moving from this larger value of 200 to the smaller value of 125. And something between the 5 and the D was happening. What was that? Well, if you think about it, for each drink, we subtract $5 from the 200. So we're going to go ahead and write minus 5D. If you think about it, if we put 1 in for D, that would be minus $5 off. If there were 2 drinks, 2 in for D, that would be minus 10 off, etc. So this gives us the story of what happened. We started with 200, minus 5 for each drink, ended up at 125. Now let's go ahead and rearrange this equation so that we have the variable as the first term, kind of like in our examples that we've done over here. So we'll go ahead and write that as negative 5D plus 200 equals 125. So this was really the hard part, is getting from all these words to an equation that we can recognize and we know we can work with, just like we worked with over in this side here. So now we want to get D by itself. Two things are bugging us, this negative 5 and this 200. As we've learned over here, it's probably easier to get rid of the 200 first. So let's go ahead and do that. You could do it either way in this example, but let's minus 200. On the left-hand side, then, we'd have minus 5D because that plus 200 minus 200 is just 0. And on the right-hand side, 125 minus 200, a little mental math there, we'll get minus 75. Okay, now, the negative 5 is multiplying by D. We want to do the opposite, so we'll go ahead and divide. And we have to do that to both sides. The left-hand side, negative 5 divided by negative 5, that's going to cancel or just be 1, so 1D. And the negative 75 divided by 5, might have to dig into your times tables for that or use a calculator. But basically, you know it's going to be positive because it's a negative divided by a negative. And it's going to be positive 15. So here we have, oops, it should say D there. D equals 15. So now let's go ahead and check that answer. Let's go ahead and put it into the equation that we came up with here. So if D equals 15, we have negative 5 times D, or negative 5 times 15. So that would be negative 75, as we know from our math over here. Negative 75 plus 200, does that equal 125? Yes. So we know that the variable here, it should say D here again, right here, is equal to 15. But what does that mean? Well, it means that the answer to our question, how many drinks did Malik buy in January? Well, he bought 15 drinks. And that's how you use these two-step equations in the real world.